Hi everyone. So the second part of the lesson today deals with not just looking at radians on the circle, but talking about how to convert between degrees and radians mathematically without having to draw out the entire circle. Okay? And there is a sheet in your notes packet. It doesn't look just like this. I didn't have a copy of it here tonight, but a page in your notes packet that just says converting between degrees and radians. Up at the top of that page it says 1 full revolution is equivalent to how many degrees and how many radians. Okay, well, 1 full revolution, 1 full time around the circle would be 360 degrees. Or, if you were in radians, 1 full revolution is equal to 2 pi. So if I know that 360 is equal to 2 pi, and I solve for pi, meaning I divide by 2, I get that pi is equivalent to 180 degrees, which you also saw that when we did the circle. Okay, you saw that pi was at the halfway point around the circle when we drew out this circle. This was 0 and this was 2 pi. So halfway around would be just 1 pi, which was the same spot we saw 180 degrees when we did degrees. So this is sort of the key fact here, is that pi is equivalent to 180 degrees. And what you're going to do with these problems is you're always going to set up a proportion. I'm either going to give you degrees and say convert to radians, or I'm going to give you radians and say convert to degrees. But no matter what, you always know that 180 and pi are the same thing. Okay, that they're the same value. So I would set up a proportion that starts with this, and then over here, this would be your degrees, because degrees go with the 180, and this would be your radians, which goes with the pi value. So if you know the degrees and you're looking for radians, you would put the degrees here, make this an x, and then cross multiply to solve. If you know the radians, you would put the radians here, you would put an x up here, and then you'd cross multiply and solve. So this is sort of the setup you're using with every single one of these problems. Okay? And I think that's at the top of your paper in your notes too. So let's try one. These are the examples from that notes packet. And the first one is 240 degrees. So here's how I'm going to set this up. I'm going to start with that 180 over pi. And since that 240 is in degrees, I'm going to put the 240 across from the 180, and I'm going to put my x there, because it's radians that I'm trying to find here. Now I'm going to cross multiply. Now when I cross multiply, though, I'm not actually going to multiply 240 times pi. I'm going to just write it as 240 pi equals 180x. Okay? And then I'm going to divide by 180. Divide by 180. Okay? So this is gone now. I'm left with this. And we want to keep our answer as a fraction. Your calculator will do that for you. So what I would do now is I would take this chunk right here, the 240 over the 180. Notice I left out the pi. And we need to simplify that or reduce it as a fraction. So in your calculator, I would type in 240 divided by 180. Now, if you just divide those two, you're going to get a decimal. But then after you type that in, you could either hit enter and then do this next part as a second step, or just do it all as one. Hit the math button. This is if you're on a graphing calculator. And then the very first option is fraction. And then hit enter. And what that's going to do is it's going to keep your answer as a fraction. Okay? So let's see. 240 divided by 180, math fraction, enter. Should reduce to 4 over 3. So this is what you should get out of your calculator after you do that. So what that means is that your final answer for 240 degrees is 4 pi over 3, Remember that pi we left out back here? We're just going to stick it right back in the answer. Okay, so we got the 4 over 3 part from our calculator and add the pi back in there. So 240 degrees would be 4 pi over 3. Okay, let's try another one of those. So your next example is 135 degrees. I'm going to start with that same setup as before. I'm going to set 180 over pi. By the way, it wouldn't matter at all if you set it up as pi over 180 instead. In fact, I'm looking at your notes right now, and I believe I actually did it that way in your notes, as long as you make sure that you line things up correctly on the other side. So on this other side, I'm going to put the 135 across from the 180, okay, because they're both degrees. My x is going to go down here because the radians is what I'm trying to find. Okay, I'm trying to find the radian value. Let's cross multiply. So I end up with 180 times x. I think I did that backwards than I did last time, but it doesn't make a difference. Equals 135 pi. Just remember that what you're trying to solve for is the x. Okay, so my next step would be to divide by 180. Divide by 180. And so I end up with my fraction that I'm worried about this time would be the 135 over the 180. So again, in my calculator, I would type in 135 divided by 180, math fraction fraction, or math fraction enter. And that should reduce to, let's see, 135 out of 180 should reduce to 3 out of 4. So then as a final answer, you would say that 135 degrees is equivalent to 3 pi over 4. Again, remembering that back here we left this pi out, so now we're going to stick it back in here for the answer. So you're never actually going to type pi into your calculator, you're just going to leave it kind of sitting there. Let's try one more of those real fast. Number 3, I gave you 780 degrees. I know that's kind of a weird angle, but it won't make a bit of difference in the process. So 180 over pi, or pi over 180, is equal to 780 over x. Cross multiply. So I get 180x equals 780 pi. Remember, you're solving for x, so I want to divide by 180. Divide by 180. And when I do this division, I want to make sure that I'm converting back into a fraction. So for my calculator, when I do 780 over 180 and reduce it, I get 13 over 3 as a fraction. So that means my final answer would be 13 pi over 3. Now I know that that's one that you're not used to seeing. That's kind of a weird answer. Remember that if we're talking about pi over 3, which is what we have here, one full time around the circle would be 6 pi over 3. So this is like 2 full times around the circle plus one more pi over 3. Okay? So this is just the same thing as we were doing before, where you had to go around the circle more than once, but you land at the same spot. So 13 pi over 3, if you were to reduce it, it would actually, well, I mean, if you were to actually find it on the circle, it would be the same place. It's just pi over 3. But you don't need to know that for what we're doing today. This answer is perfectly fine. Okay, let's try a couple of the radian ones. So your next example gives you pi over 6 and wants you to convert that back to degrees without having to use the whole circle. So I'm going to stick with that 180 over pi, except this time the pi over 6 is going to go down here on the bottom because that's a radian measurement, and this is now my x. Okay? So this is going to be a little weird. When I cross multiply this, I'm going to get 180 pi over 6. Okay, that's how I would multiply that. 180 times pi divided by 6 equals pi times x. Now what I would do over here is go ahead and do this division. Okay, so here I get 30 pi, because 180 divided by 6 is 30, so 30 pi equals pi over, or pi times x. And then in this one, I can just cross off my pi's, and I get 30 degrees for my x value. And that's my answer. Pi over 6 is equivalent to 30 degrees. So in this one, you're going to end up really just doing the 180 divided by whatever this fraction is. Okay, or by whatever the denominator of the fraction is. Your next example, number 5, is 5 pi over 3. So if I set this up, 180 over pi equals x over 5 pi over 3. And again, maybe I should write that the other way. I knew to put the 5 pi over 3 on the bottom because it's a radian measurement. Now, had I set this original fraction up the opposite way, had I put the pi on top, then I would put this on top also. You always want to make sure these are your degrees, these are your radians, and my x is here because my degrees is what I'm trying to find. Okay, when I multiply this, here's what I'm really typing into my calculator. 180 times 5 divided by 3. I'm not touching that pi at all. So 180 times 5 divided by 3. I believe I get, let's see, 300. Okay, so just that first round of multiplication, multiplying these two together, I get 300, and I still have this pi, so 300 pi, and that's going to be equal to x times pi. But again, in these ones, they're always going to work out like that, where you have a pi on either side, so your answer is just 300 degrees. That 5 pi over 3 is equivalent to 300 degrees. Okay, and one more example. So again, they're giving you a radian measurement here. I'm going to start with my 180 over pi. As long as you can keep that 180 over pi in mind, you should be in good shape. My 10 pi here is going to go on the bottom. My x is going to go on the top. When I multiply, I'm going to do 180 times 10 pi, okay, which is going to be 1800 pi. Just did 180 times 10. That's going to equal pi times x. And let's get rid of those pi's, and I find out that this is actually equivalent to 1800 degrees. Now, to find that on the unit circle, I would take that 1800 and subtract 360 a whole bunch of times. Okay, but this isn't asking you to find it on the circle, it's just asking you to tell how many degrees is it equivalent to. So that's all there is to it. So for every single one of these problems, you are setting it up in this proportion. Start with the 180 over pi. You're always starting with that because these two things are equivalent. This is the definition of a radian. These two things are equivalent. And then when you set up your other fraction, if they've given you a radian, put it across from pi. If they've given you degrees, put it across from 180. Cross multiply. Okay? Tomorrow we will go over some of these just to make sure that you aren't getting mixed up on your calculator or anything. But really you should be good to go. That's all there is to this.